Welcome to The Explainer. Today, we're going to dig into something that's literally all around us, the hidden force that built our entire world, the story of measurement.
Think about the smartphone in your hand or the tallest skyscraper you've ever seen. Everything, and I mean everything we've built as a civilization, it all comes down to one single crucial skill. And you might be surprised what it is.
It's all about measurement. That's it. You could say that the entire story of human civilization is really just the story of us learning how to measure things. Taking the chaos of the natural world and trying to give it some order.
All right, so let's jump in. We're starting way back in the ancient world, where these first attempts to create order really set the stage for everything that came after. So the first standards were just brilliantly practical. They used what was right there. The Egyptians, they used the pharaoh's own forearm as a standard length, the royal cubit. And guess what? It was good enough to build the pyramids. For weight, they'd use whatever was handy, like stones or even little carob seeds. And get this, that's actually where we get the word carat that we still use for diamonds. And even the mighty Romans, with their huge empire, they shipped goods in these clay jars, amphorae, that weren't all perfectly the same size. It just goes to show you, back then it was all about practicality, not perfection. And this really gets to the heart of it. For most of human history, measurement was all about being good enough. It just had to work for what you were doing right then and there. It's a world away from the kind of crazy precision we expect today for, everything we buy. But then, things started to change. Fast. As we started to explore more, as industry took off, suddenly, good enough just wasn't good enough anymore. There was this desperate, urgent need for a whole new level of accuracy. And here's a perfect example, the longitude problem. See, out on the open ocean, a regular clock was totally useless. And if you can't tell the time accurately, you have no idea how far east or west you are. You're basically lost. It was such a huge deal that Britain put up a massive prize. We're talking life-changing money for anyone who could solve it. And that's how we got the chronometer. This thing was a beast, a tough sea clock that could handle the rocking of a ship. It didn't just tell time, it literally conquered the oceans. Okay, now this is kind of wild. The journey to measuring really, really small things actually started by looking at the biggest things imaginable, the stars. Way back in 1638, an astronomer figured out he could use a screw thread to make these super fine adjustments to his telescope. He wasn't building something, he was trying to measure the cosmos. Flash forward over 100 years, and who do we see? James Watt, the steam engine guy. He took that exact same idea, the screw thread, and brought it down to Earth, creating this tabletop micrometer. It was a huge step forward, for sure, but look at it. It was big, clunky, and had to be bolted to a workbench. And then, in 1848, we get a moment of pure genius from a French inventor named Saint-J. Palmer. He looked at that big machine and figured out how to shrink the whole principle down into this amazing, compact, U-shaped tool you could hold in one hand. And just like that, the modern micrometer was born. This is the design that's still a staple in workshops all over the world. So here's the really big takeaway. This jump in precision wasn't just about, getting more accurate numbers. No way. This was the key that unlocked the entire modern industrial world. For the first time, you can make identical, interchangeable parts. And that idea, that's the bedrock of the assembly line of all mass production. It changed everything. Okay, so we have precise tools. That's one piece of the puzzle. But for this whole mass production thing to really work on a global scale, you needed something else. You needed a universal standard, a single source of truth that everyone, everywhere, could agree on. And the answer came in 1896, and it looked like this. These simple, unassuming little blocks of metal, invented by a Swede named Carl Edward Johansson, they're called gauge blocks, or Joe blocks for short. And they are so ridiculously precise that you can stack them together to create any exact length you need. These little things, they completely change the game in manufacturing. Now, the secret here is a really cool process called ringing. It's not glue, it's not a magnet, it's something way cooler. When you slide these two incredibly flat, smooth blocks together just right, you push every last molecule of air out from between them. And what's left? The natural intermolecular force. The atoms of one block are literally attracted to the atoms of the other. They basically fuse together. And that bond is strong. We're talking strong enough to resist a pull of 300 newtons.
To put that in perspective, that's like hanging a 66-pound weight from them. They just cling together like magic, forming one single, super precise block of a specific length.
So, who was one of the first people to see the power in this? Of course, it was Henry Ford. He actually bought Johansson's company. He used Joe blocks to make sure that a part made in one factory would fit perfectly with a part made in a totally different factory. This right here was the missing link. It created a universal language of measurement that basically fueled the entire 20th century economy. All right, let's fast forward to the modern era, because the next leap in measurement was a huge one. From the world of gears and screws to the world of electronics and even quantum physics. So, just like Palmer's handheld design was a revolution in its day, the digital age completely transformed measurement all over again. The micrometer went from having these little mechanical dials that you had to squint at to having a bright, clear digital screen. And that one change was massive. It pretty much got rid of human error and made taking precise measurements faster and way more reliable. And the story is just as dramatic when you looked at how we weigh things. I mean, we went from a simple balance scale, literally balancing something against a pile of rocks, to modern scales that use something called surface acoustic wave technology. The accuracy is just mind-boggling. We're talking about scales so precise, they're absolutely essential for things like developing new medicines or doing high-level scientific research. So where are we today? Well, our ultimate gold standard measurements aren't based on a king's arm or some block of metal in a vault anymore. Now they're tied to the fundamental laws of the universe, things that will never, ever change. Take temperature, for example. Our best thermometers are calibrated against the exact known temperatures where elements change their state, like the triple point of argon. That's the one single unique temperature and pressure where it exists as a solid, a liquid, and a gas all at the same time. You literally can't get more fundamental than that. This is the absolute pinnacle of precision. So, after this whole incredible journey, what's the big idea? What's the main takeaway? Well, it's this. From a pharaoh's forearm all the way to the triple point of argon, our ability to build, to explore, and to understand has always been defined by our ability to measure. Every single time we got better at measuring things, it unlocked a whole new chapter for humanity. And that leaves us with one last really exciting question. We went from measuring limbs to measuring atoms. Each one of those leaps completely remade our world. So, as we get better and better at measuring things on a quantum scale, what are we going to build with the measurements of tomorrow?